Joule-Thomson coefficient. Joule-Thomson coefficient. Joule-Thomson coefficient. And Joule-Thomson coefficient, what is there in the background? A gas has been subjected to adiabatic expansion. Adiabatic expansion. A gas has been subjected to adiabatic expansion. So what will happen? You can see the cycle tubes. When valve is open, air gets condensed in liquid format. So what is happening? Air is coming out from very high pressure to low pressure. So P1 minus P2 is negative. P1 is high pressure, P2 is low pressure. It's a mu Jt is equal to change in temperature by change in pressure at constant heat. Rate of change of temperature with respect to pressure at constant heat. Mu Jt is suppose this one is positive. Suppose mu Jt is positive. What will happen? Mu Jt is positive. What will happen? This part is positive and we have taken pressure P1 minus P2 as a negative. Because initial pressure is higher and final pressure is lower. Now this one is delta T. It can be, this parameter will come positive only when this parameter is negative. This will come positive only in the condition when this is coming negative. So we know that for this to satisfy this condition, delta T must be negative. If it is negative, it means T1 minus T2 is negative. It means T1 is higher than T2. It means cooling has taken place. It means cooling effect has taken place. So if Z is equal to positive, it means if Z is equal to positive, it means if positive is there, it means when a gas is subjected to, gas means real gas. When a real gas is subjected to, Joule-Thomson coefficient, Thomson experiment, it will undergo cooling or fall in temperature will be noticed. Now what will happen if mu Jt is negative? What will happen? And here example is all real gases except hydrogen and helium. Now mu Jt is negative. In this case, what will happen? We know del T by negative. Why negative? Because P1 minus P2 is equal to negative. To make it negative, dt must be positive. Dt has to be positive. It means T1 minus T2 is positive. So this will go like this. That it has to be P2 minus P1. P2 minus P1 is negative. Since P2 minus P1 is negative, to get this parameter positive, to get this parameter negative, to get this parameter Joule's Thomson coefficient negative, this is negative and this one is negative, so it should be positive. It is positive. Positive means T2 minus T1 is positive. It means T2 is greater than T1. When T2 is greater than T1, it means heating effect takes place. So it is not P1 minus P2, it's a P2 minus P1. If mu Jt is equal to 0, neither heating nor cooling takes place. And example is all ideal gases. Mu Jt is negative for hydrogen and helium. They ask this question. They will put the value of hydrogen and helium in a negative format and they will ask for this, what is the value of mu Jt. So if hydrogen and helium is given, mu Jt is negative. If mu Jt negative is given, hydrogen and helium is the example of this. One more part is there, inversion temperature. Actually these things are not directly in the syllabus. They have given in the indirect form. You have to read this inversion temperature and other things in the thermodynamics of physics. But here also we are having a glimpse of all these things. Inversion temperature means it is the temperature up to which a gas shows cooling effect above this temperature they show heating effect. It is written as TI. It's a 2A by RB. Ti is equal to 2A by RB. And here only one temperature is there, TB, boils temperature, which is A by RB. Boils temperature is defined as temperature up to which temperature up to which an ideal gas, a gas, obviously it's a real gas, follow Boyle's law. Boyle's law. Sometimes they ask ratio of Boyle's temperature to inversion temperature. They are not given directly in the syllabus, but it's in direct format. So we can put the value of TB by TI and you will get the answer 1 by 2. TB by TI, answer is 1 by 2. Or if the reverse is TI by TB, then answer is 2:1. Here A and B is the van der Waals constant. In both of the equation, A and B is the van der Waals constant and R is the universal gas constant.